Hello there. Welcome to another problem session. So today we are going to do a very simple set of problems, and all of them have to do with image location characterization, or in a concave mirror setting or a convex mirror setting. You from the previous video, you probably know already that if the object distance is P and image distance is Q and radius of the mirror is R, then we have relation 1 over P plus 1 over Q equals 1 over F, and F is defined as R over 2. Now, depending on the type of mirror, it may be plus or minus, okay? And this can also be plus or minus. Another relationship is magnification, is height of the image over height of the object. So if this is horizontal line, the object is that way, and the image is that way, this height will be negative and this height will be positive. If the image is also this way, then both will be positive. And from geometry, you can show that this is related with minus Q over P, with appropriate Q and P signs. Okay. Using this information, all we need to know is the plus minus sign of F, and for concave mirror it's a plus and convex mirror is negative. And this sign conventions comes from, so if I have a mirror here and if it's silver this way, that's concave. If I'm like this and if silver this way, then this is convex and this is concave. So if I place the object this side and I want this distance to be positive, so we take a positive distance like that. So you can see that the radius of curvature, the center will be here and the focal length will be distance here. So you can see the focal length will be also positive here, and any image forming this side will be positive, image forming this side will be negative. Over here, object has to be, if I have a mirror like that, the object has to be this way. If your object is here, then there is no image formed. Object has to be in front of the mirror. So in this case, I will have center will be here and the focal will be halfway there, and distance from here, so focal will be negative, but the object distance will be positive. And here the image will be forming over here or maybe over here, but image will be to the left and image will be on the negative side. So this is the sign convention. Let's see how we're going to do this problem. So here we have a magnification is 2 centimeter over 3 centimeter, and because it's a real image, it's going to be inverted in a concave mirror. So that's coming from geometrical way of looking at it. So this is something I'm putting inside an information. So minus 2 centimeter tall over 3 centimeter, and that should be equal to minus Q over P. So we say Q is 3/2 P. That's one equation I get. And then other equation will be here, and here we want to find out where should the object be. So the question is about P, so we want P. So this is not enough information. From here we have 1 over P plus 1 over Q and 1 over F. So over here f is positive because we have a concave mirror, so this is f is equal to plus 20 centimeter over 2 is 10 centimeter. Now I want p, so I can replace q with this, so 1 over p plus q will be 3p, 2 like that, and f will be 1 over 10. So now this I need to solve for p, and let me just solve it like this. 1 over p will be 1 plus 2/3 equals to 1 over 10. Pause it. I see I made a mistake. This should be p goes on the other side. This should be 2/3. So this will be 2/3 here. This is 3/2 because. All right. So this is equals to 1 over p times 5 over 2 equals 1 over 10. And so the p on this side and 10 on the other side. So p equals to 10 times 5 over 2. And that's just 25. And the units of distance, all the units are in centimeters, so this will be 25 centimeters. Okay, so this should solve this very simple problem. Okay, let's try another problem. Okay, so this second problem is same problem, but this time I'm going to work over convex mirror. And this time it's going to make virtual image. That's the only kind of mirror in convex mirror. So if the inside is silvered, so the object can be in front. This is the front of the mirror. So when you place an object anywhere, the image can be, so this is the center and this is the F and this is the vertex. So this image will be same, so the image will be somewhere here, but this will be enlarged image or small image depending on where it is. So for instance, let's see how in this distance this will be, you will get a ray like that, parallel ray, and which seem to be coming out of this because this will be the normal and this angle is same as that angle. And another ray will be if you send towards the center, then it's going to get reflected. So this and this, so over here is going to be a small image and it's going to be right side up. But if I were to do an object which was, so object was say over here, this focal distance, but I'm over here close to the mirror, then what will I see? What will have one ray like that, another ray will be going towards that, so it will be, it's also be small. So you can see that the image here is always very small and it's forming around here. So if you're looking at it, you can just look at the image over here. So it can cover a whole bunch of space in here. Concave, this is the C and this is the F. So we already learned that if you had a object here, then there's the parallel ray which go through the focal length, and the other one could be going through this and come back. So if this is the object, the image will be formed over here, and the image will be like that. So if the object is here, but if the object is say inside here, then the image will be formed. One ray will be just like before, but then the other ray will be, well, it's pretty hard to draw this ray now, because we'll draw another one, go through this vertex, then it's going to be symmetric. So this, and this can be actually diverging, and it's going to be making very over here very large. So it will be, this will be the image enlarged, virtual image, and this is a real image. So it's going to form real image and virtual image depending on where the object is. But over here it's going to always form the image, virtual image. So you can see that if I have this as a positive distance, because this object is going to be positive, then the focal length, so f becomes negative, and the image distance q becomes negative in this situation. Over here, this is the situation more complicated depending on where it is. This q can be this is negative. If this side is all positive, then this q will be negative. But f is, so this is p is positive, f is positive, and q real is positive, but q virtual is negative. So those are the signs. That's where science comes in. So let's do this problem with that. So here m is going to be hi over ho equals to minus q over p. This will give me, because this is virtual, it's going to be, hi will be positive. So this is positive height and this is positive height. So it's going to be 2 over 3 for this, and minus q over p. So q is minus 2/3 p. So that one equation. And the other one will be 1 over p plus 1 over q plus 1 over f. So with f here is equal to, this is going to be negative, right? Because this is going on the other side. So f is equal to minus 20 centimeter over 2 equals minus 10 centimeter. So now put in here. So I want to find p. So one question is about p. So 1 over p, and the q is minus 3 over 2p. So 1 over q will be minus 3 over 2p equals minus 1 over 10. I need to solve for p. So 1 over p is 1 minus 3 over 2p equals minus 110. And then minus half p equals minus 110. So p equals to 5. All the units are centimeters, so it's going to be centimeter. So this is centimeters, this is centimeter. So in this case, if this is 20, this is 10, so the object is very close. So that's where the object is, 5 centimeter. So that's the answer. Okay.